This is a problem from chapter 16. It's problem 34 called pets. I've also given this as a quiz problem, primarily because I want you to work on calculating the difference in random variables. So this problem is about the cost, the medical cost, so the medical care of costs of dogs and cats. Okay, so what they want to know is what's the difference between the two. So that might be an interesting thing if you're thinking about getting a dog or a cat. So I should define my random variables, D and C, but we'll just do that verbally. We're going to let D be the cost of medical care for dogs and C be the cost of medical care for cats. So the difference is D minus C. So that's just the expected value of dogs minus the expected value of cats. So that's just going to be 100 minus 120. So we get an expected value of negative $20. Now to find the standard deviation, we would first need to find the variance. So the standard deviation of D minus C is going to be the square root of the variance of D minus C. Okay, so the square, let's see, the variance, so remember that the variance of a random variable plus or minus another random variable, we always add. Doesn't matter if we're subtracting or adding, we always add the variances. So that's going to be the variance of D plus the variance of dogs plus the variance of cats. So that's just going to be, let's see, the variance is the standard deviation squared, so 30 squared plus 35 squared, and that comes to $46.10. Okay, so now they're telling us if the difference in cost can be described by a normal model. Okay, so let's see if we can do that. Let's just draw a picture best I can. There's my picture. So the center is negative 20. Okay, so we have a normal distribution with minus $20 and a standard deviation of 46.10. Alright, so this is dogs minus cats, that difference. Alright, so that's our model. Now it says what's the probability that the medical expenses are higher for some dogs? So probability of D minus C. So if dogs was higher than cats, then it would be greater than 0. Okay, so let's see. That's going to equal, so we need to remember this, our Z calculation. Z is, for the normal model, x minus mu divided by sigma. So mu is the expected value and sigma is the standard deviation. So we can write this is the probability that Z is greater than 0 minus negative 20. So you have to be careful here. Divided by 46.10. Okay, so that's going to equal the probability of Z greater than, if I do my computations right this time, it's going to be 0.4338. Okay, so now let's see, let's go over here. If this is negative 20 and one standard deviation would be here, that's 46. So zero's somewhere over here. Can't quite tell where. Somewhere in here. Alright, so this could be approximated or by normal CDF, and we want to go from 0, which is now on the normal model 0.4338, so 0.4338 to infinity. This is going to go on forever, so 999. Okay, so that's going to end up being 0.332. That's what I get. So approximately 33.2%. So according to the model, we expect the cost of care for dogs to be greater than cats, greater than the cost of cats, 33.2% of the time over the long haul. Okay, so I'm going to stop the video here, and we're going to continue with the second video for this problem, which is problem 36.